So in the previous video, we discussed about the relationship between the linear and angular displacement as well as the velocity. Now in this video, we discuss about the relation between linear and angular acceleration. Okay, so if we talk about the linear, you can say that the acceleration and the angular acceleration. So we were having a formula that is the, if we talk about the linear, so we were having a formula that was the change in velocity, linear velocity upon time. Here we are having alpha, we are denoting as an angular, that was equal to the change in omega, which was change in angular velocity upon change in time. So here you can see that this was the formula of both. So here you can see that this acceleration is different and this acceleration is different, but this is angular, this is linear, so they are having no relation between them. So for relation we want to make a one formula in which both terms will come. Okay, so we have to here you can say this value is not here, this value is not here, so we have to make a relation. So let change in linear velocity and change in angular velocity be the change in linear and angular velocity. Okay, so here you can see we are having a formula that is this. Okay, and here we are having a formula of the angular, or you can say the acceleration, that is this. Okay, so this is equal to what? This is the equal to the linear acceleration, and this is equal to the linear you can say that the not linear alpha, which is the, you can say that this is the angular. So I can write over here that this was a radius here. Okay, so I can write here that this value as a is equal to r, and we have considered this as a alpha, which is the angular acceleration, so I can write a here. Okay, so this is the formula of the relation between the linear and the angular acceleration. So linear acceleration is also called a tangent acceleration. Linear velocity was also called as a tangent, you can say that the velocity. So we can write, if I want to make a formula of the tangent velocity, and as you guys all know that previous video, tangent velocity was equal to the you can say that we were having a relation between linear and angular velocity. We were having a formula, and with that formula I just put out there as a tangent. So this we are having a formula, I will put just a tangent. So tangent acceleration, so acceleration, but what tangent acceleration is equal to the r and a. So this is what, this is the tangent acceleration. Okay, so what will the definition of the tangent acceleration? That means that the product of the position vector, this is what, this is the position vector, the product of position vector and the angular velocity is called the angular, or you can say that tangent. Okay, or you can say that the tangent acceleration. So this was the last relationship between the angular and the, you can say that the linear acceleration. Here you can see that both terms are now in the one formula, this one and this one. Both were different, linear and angular. Now we are having a mix-up formula through which we can use easily. So this is the formula of the relation that we have find it out. So this topic is clear, that the relationship between the linear and the angular quantities. So this was the last relationship. So in the next video we'll discuss about the new topic, that is the centripetal acceleration.